Hi, this is Giuseppe Massoni and welcome you all to Paneling Tools and Grasshopper for Jewelry Design video. Paneling Tool is a plugin wrote by Raja Issa. All the information can be found on the McNeil wiki page. It's mainly used in architectural area, but we will try to use it in jewelry design. If you scroll down the page, you find information about how to make what downloads are available, other information like documentation and videos, and how to provide us with feedback on the plugin. So let's start from the finished object. This is the ring we want to design and to make in Rhino using Paneling Tools and Grasshopper, and you'll see that it's not so difficult to accomplish. So let's start with a very fast overview concerning the features of Paneling Tools. As you can see, the plugin is available with a pull-down menu. You have all the submenus there, menus and submenus, and also as a toolbar, separate toolbar with the same commands there available. As an example, I have this slightly double curvature surface here, which we want to populate and create a grid on top. We will use a very simple example here, and we want to use the surface domain as the criteria to create the grid. So that was our choice. We have a number of spans both in the U and V direction. You see we have, despite the number of span is the same, we have different sizes, different dimension of the spans because of the size of the surface. You can count them there. We have 12 of them. So I have chosen also to group the points so that it's easier to handle them. And then we have our grid. It's very easy. Now what we want to do with the grid is to panel it with the panel to D command, panel to D grid. So we select the points. We will use some options here like add flat faces. You see on the left side you have different patterns, but we will use box for the time being. We will name the group and we will group the objects. Now as you see, from a double curvature surface here we have a number of panels that are flat panels, and of course if you think them from an architectural standpoint, it's much easier to manufacture things when you rationalize them to small and handy pieces rather than just thinking about one large object to produce. So after having seen the very basic of paneling tools, let's see how we can apply this plugin using the ring shank that I have designed for you. It's rectangular topology, just as the previous surface we've seen. It has parameterization. Let's check the details of the object. You see it's a valid surface. It's an untrimmed nerve surface. And right down here you can see the domain in terms of U and V. Okay, that's it. And I was saying it's rectangular because you can count 4 edges. One of them is this, the other one is the other side of the surface, and then down here we have 2 edges that are overlapping in what it's called a seam. So this is the Grasshopper interface that I'm sure all of you know about, and we have a panel with a few words on the background of paneling tools. Okay, this is the area where the paneling tools components are. We have components for curves, grid, attractors. We will speak about them a little bit later. Utilities, all of the components available. So what we're going to do is not much difference from what we did previously on the surface, and except for the fact we're going to work in Grasshopper. So first thing, we'll get a surface component parameter and set that surface to that component. Next step, we're going to get a grid component which is based on surface parameter. Okay, that's the input for the surface, that's for the U parameter, that's for the V parameter. And we have one more input that we're not going to use for the time being. So one thing to remember is that you pretty much have little control over how Rhino will parameterize a surface both in U and V. You see the numbers are really unpredictable. But we need to have some degree of control over them, and I'll show you in a while how to do that, because those numbers are going to feed the U and V input of the component. So let me just plug in the surface to the input, and one thing we're going to do now to sort out the problem is reparameterize. You see, we have this option in the input, and so whatever the parameters are of the surface, they will be boiled down to an interval that goes from 0 to 1. Okay, now to drive the U and V input, we are going to use a component which provides with a range of numbers. You see, given those inputs, we have 0.1, 0.0, 0.1, 0.2. You see, those numbers are all within the interval 0, 1, which is exactly what we need, within numbers that are in that interval. We're going to replicate the same thing for the V parameter. And now we would like to have some degree of control over the number of steps we have in that range. For the time being, we have 10 steps, but maybe we want to have something different. So we're going to use a slider parameter to help us change the input number. That's the slider parameter we're going to use for the input. We're going to use integers, and let's say we will choose a range that goes from 0 to 50 maybe. Okay, we plug the slider to the number of the range. We copy paste the same slider and plug it to the other one. So you see that we are increasing, let's say 10 in U and V, and that's pretty much would give us the same result we were having before. Okay, you can check the output. But say like you want to decrease that to 4, now the output would be different. Okay, and those numbers are feeding the U and the V's. Now let's see what happens in the real situation. I'm choosing to just show in Rhino and in Grasshopper, sorry, what's been selected. So I will select the point surface parameter, and now let Grasshopper show its result, and you see that we have a surface that's been divided in once on the U side in 10 steps and in the V side in 4 steps. Of course, you can change the numbers. That's the reason why we've selected to use a slider. You see, you increase them, and the increase will show parametrically on the surface. Same thing applies to the U direction. So it's really your choice to decide what numbers you prefer. This is the grid that we've chosen to populate with some geometry, which is now hidden. Let's show the parts we need, not really all of them. We will be playing with the hexagon for the time being, so maybe I can hide the circle and its projection over the surface. We will use that later as a curve attractor. So go back to Grasshopper. Let's go back to it and use the Morph 2D component. You see it requires an input, a grid input, uh, curve, pattern curve, and then two more inputs we will not be covering for the time being. So let's go to parameters, select the curve parameter, we will put it down on the canvas, and then select the hexagon and set that one as a curve. We plug it to the curve input, the grid, and there you go. You have the hexagons showing on the surface and paneling the surface according to the slider values we've selected. And no need to say that you can change values. You see that will, according to how you slide the values, you get different shape and different density of the hexagon. If you're happy with the result, you can bake the result so that it will become real rhino geometry. As mentioned before, we are now going to use some curve attractor to change how the layout of the points will look like. So within the components, we use a curve attractor, and to do that, we'll need the curves we just hidden. That one, the circle was projected on top of the surface. You can see it there. We just need that one actually, so we'll just stay with that. Okay. And we will want to set our curve that was previously connected to the hexagon. This time we will connect it to the circle. No surprise, the layout will look like this. And let's get the curve attractor component. You see it has a grid input parameter that will be connected to our grid. There is a surface required, and that's going to be the shank of our ring. There is also a curve, which is the curve attractor, is the curve that will change the behavior of the population of the geometry on the surface. You see that's going to be the curve. And last but not least, there is a magnitude input that we can handle. And a slider will help us. You see, you can double click on the canvas and start typing the name of the component you want. That's a slider. Double click, 2 decimal places is more than enough. There is a minimum value of 0 and 5 is maximum. Let's connect it, and that will give us the range of effect of the magnitude of the curve attractor. So what happens, and let's see how in practical this happens. You see, you turn on, you boost on the value of the magnitude, and the points will sort of like flow towards the curve, hence the name attractor. There's not much happening inside the circle because we have very few points, and some of them are very close to the curve. But see what happens to the points that are outside. You see how they get attracted by the curve. There you go. Now if you boost up the magnitude, you see that the more you go up, the more attraction effect you have on the curve. And of course the shape of the circles will change accordingly. They will all try to go up where the curve is. No need to say that all this depends on the amount of divisions, so the amount of circles. You can tweak all these values together in order to get the result that you're looking for. In this case, probably the density should be reasonable with the manufacturing specification. So you have too many small circles, probably they will not cast, or you might run into other kind of problems. So you have to really tweak the values according to what you're after in terms of shape and everything. And what's next really doesn't have to do much with Grasshopper or paneling tool. Is just explaining how the rendered image was obtained. Um, I really didn't want to make a panel out of the whole surface, even on the lower part. I like this interruption of full metal to show at, at times. So what I did was just splitting the surface with isocurves. There you are. I'm snapping to some knots on this surface. You see, so that I have the upper part, an intermediate part right close to the bottom of the ring. And now one thing I'd like to mention here is although I've split with isocurves, yes, of course, in Grasshopper the original surface is no longer there, so you need to associate that surface with a new split surface. Otherwise, you get this warning, an error message that you're seeing on the on Grasshopper canvas. So what I have to do at this time is just check 1 second one of the pieces, and you see, if you turn on the control points, they will look just the same as before. That's because this surface is, remember, it's untrimmed version. If you really want to shrink the surfaces to the size they are right now, you have to use the shrink command. That's what I did. And now if you look at the control points, you see that they are shrunk to the actual size of the surface. You do this streaming by isoparm. That's really important in order for this command to take the effect we're looking for. So now, there you go. If you check the details of the object, it will look like it's not a trimmed surface. That's important, so that the result is predictable. The control points are just confirming this. Oh, that's not very much connected to Rhino, you see. It's not connected to Grasshopper, it's connected to normal Rhino modeling. Now we will associate that surface to the input. You see now that the numbers are too high, and we're getting circles that are very cluttered and are not the shape we are looking for. You see how important it is to tweak the values. In this case, the magnitude of the point the attractor towards the curve is too high, and it's like deforming too much the circles. So it's a balance of the right amount of magnitude and the right number of circles. As I said before, you want to keep somehow production in mind, and you don't want to go with details that are too small. You tweak these values to something that is reasonable, still a bit too much tension or attraction, as you want to call it, from the attraction curve, and now it looks like it's something reasonable. At this point of time, you may want to make a pipe out of the curves, so you can get some volume that is castable. So we get the pipe component, and all we have to do is assign a radius. I'm working in millimeters. It's going to be 0.2, so that the finished piece will be like 0.4. It's a bit thin, but it's just a demo, so I'm not worried about real production at this point of time. and Grasshopper will think it over a little bit, and finally we get the pipes. So what you have to do now is to bake the parts, which is what we're doing. You have a chance to choose the layer and other options. I would use a group command. I use it all the times. And there you go. We can hide Grasshopper, and we're in Rhino with all the pieces baked and ready for a boolean that will join them all together. And this is pretty much how the ring was made. You can see the upper part shows the effect of the attraction curve on how the shape of the ring looks like. Once again, this sample is not meant for real production, and now I'm selecting the other piece, and we will apply the same definition also to the lower surface, so to have other pipes, other circles, other pipes, and obtain the ring that I was showing to you at the beginning, and maybe you would like to see at the end of this video. So once again, the definition is really easy, and to obtain the lower part we will just have to play with the magnitude as well of the curve attractor, with the sliders connected to the U and V of the point division, of the surface division, and that's how we obtain the ring. Once again, please try yourself, investigate. It's a nice way of thinking jewelry in a different way, and I hope you enjoyed the video, and we'll be using paneling tools and Grasshopper a lot. Thanks.